Hello students, welcome to the lecture number 15 of chapter 6. In this lecture we are going to discuss about a new theorem related to the parallel lines, that is theorem number 6.6. So let us first understand the concept of the statement of theorem 6.6. Right? So here according to the theorem 6.6 it is given that lines which are parallel to the same line. So we will first understand this statement clearly. As you can see, there is a word lines. Lines means either there are two lines or more than two lines. Okay. So here we have considered two lines, AB and CD. Okay. There is no relationship between AB and CD. Simply it is given that AB and CD are two lines. Now, the two lines are parallel to the same line. It means here the line AB and the line CD are parallel to a common line. Okay. Suppose PQ is that common line which lies in between AB and CD. Okay. So we have taken PQ as a line which lies in between AB and CD such that these two lines are parallel to the common line PQ. It means according to the statement is given that the line AB is parallel to the line PQ and the line CD is parallel to the same line PQ. Okay, so both these two lines are parallel to a common line, but there is no relationship between AB and CD. No, AB and CD are parallel or not parallel. It is not given in the statement. Okay, either AB may be parallel to CD or AB may not be parallel to CD. It is not given in the statement. Simply it gives that these two lines AB and CD parallel to a common line PQ. Okay. Then you have to prove that these lines are parallel to each other. So what you have to prove? You have to prove that AB is parallel to CD. You have to prove this statement. AB is parallel to CD. You need to prove this. And what you have the condition? You have the condition that AB and CD are parallel to a common line PQ. Okay. From this condition, by using this condition, you have to prove that these two lines are parallel. Understood? So let us prove. So first we have to write what is given in the question. Given. It is given that AB, PQ and CD are three lines. AB, PQ, CD are three lines and AB is parallel to PQ, CD is parallel to PQ. This is given in this statement. Now what we need to prove? We have to prove that this line is parallel to this line. Right? So AB line is parallel to CD line. Okay? So in order to prove this statement AB parallel to CD, we need to first draw a transversal line which intersect all the three lines. Okay, this is the construction. You have to construct or you have to draw a transversal line MN which intersect these three lines at three distinct points. Suppose the three distinct points are E, F, okay, and G. You have to construct this transversal line. So in the construction section, you have to write this. Construction. Draw a transversal line MN which intersect three lines at E, F and G point. E, F and G. Okay, this is a construction. This is a transversal line which intersect these three lines at three distinct points E, F, G. Okay, now you have to prove that AB is parallel to CD. Now think, how can we prove that AB and CD are parallel? Which condition should satisfy so that these two will be parallel? If according to the 6.4 theorem, 6.4 axiom, you remind, according to the 6.4 axiom, if we can prove that the two corresponding angles are equal, then these two lines are parallel. Okay, so if we can prove this angle and this angle, they are corresponding, are equal, then we can say yes, this line and this line are parallel. Okay, so here also in this case, if we can prove, forget about the line PQ. Okay, consider only the transversal line MN which intersect AB and CD at E and G. Forget about PQ. Now, if we can prove this angle and this angle are equal, these two angles are known as corresponding angles. So, if we can prove these two corresponding angles are equal, then we can say yes, AB is parallel to CD. So, our basic target is to showing these two corresponding angles to be equal. Okay, so let us prove them. Okay, now since it is given that the line AB is parallel to the line PQ, it is given in the statement. Okay, so AB line is parallel to PQ and MN is a transversal line and MN is transversal. Okay, so in this figure you just consider AB line and PQ line. AB and PQ are parallel and MN is a transversal line which intersect these two lines at E and F. Now remind the axiom 6.3. According to the axiom 6.3, we have studied that if a transversal line intersect any two parallel lines, then the pair of corresponding angles formed are equal. We have studied it. So here the transversal line MN is intersecting these two parallel lines at the point E and F. So we can write that their corresponding angles are equal. So we can write this angle is equal to this angle. Right? So this angle means BEM is equal to QFE. Why? According to the axiom 6.3. Because they are corresponding. Understood? Then, now consider the line PQ and CD. It is given that CD is parallel to PQ. Forget about AB. CD is parallel to PQ. Right? And MN is a transversal line. So let us write it first. CD is parallel to PQ. Okay? And MN is transversal. Okay, first consider it as equation 1. Okay, so here the line CD is parallel to the line PQ and the line MN is transversal line. Then similarly, according to the axiom number 3, if a transversal line intersecting any two parallel lines, then the pair of corresponding angles formed are equal. So here this MN transversal line intersect the line CD and PQ at two distinct points F and G. So we can write that their corresponding angles are equal. Here these two are known as corresponding angles. So we can write this angle is equal to this angle. Okay. So this angle means QFE is equal to which angle? This angle. This angle means DGF. So let us write this angle first. So this angle is equal to this angle. DGF is equal to this angle QFE. You can write any angle first, but for my convenience I choose this angle to be written first, then I choose this angle to write. Okay. So according to the axiom number 3, if a transversal line intersects any two lines at two distinct points, if these two lines are parallel, then the pair of corresponding angles are equal. So here these two corresponding angles are equal due to axiom 6.3. Now this is equation 2. Understood? Now the next thing, we have to compare these two equations. Okay? So I am writing here, comparing equation 1 and 2. As you can see, in equation 1, the right hand side contains the angle QFE, and in the equation 2, the right hand side contains the angle same QFE. So in both the equations, the right hand side are equal. Okay? As you know, if in any two equations, any one side are equal, then we can write that another side must be equal. So the left hand side of equation 1 and the left hand side of equation 2 must be equal. So you can write BEM of equation 1 is equal to DGF of equation 2. Okay? So after comparing equation 1 and equation 2, we get the result that the angle BEM means BEM, this angle, okay, is equal to DGF, this angle. Now tell me, which type of angle these are? These are corresponding angle. This is a transversal line. It intersects AB and CD at 2 points E and G, and these two angles are known as corresponding angles. And what we find? We find that two corresponding angles are equal. Okay? So, and they are corresponding angle. And according to the axiom number 6.4, we studied, if any two corresponding angles are equal, then the two lines must be parallel. Here the corresponding angles are equal, we find it, so we can write, hence AB line, this line is parallel to this line CD. Why? Due to axiom 6.4. Hence, we proved it. Understood? So, if according to the 6.6 theorem, if any two lines are parallel to a common line, are parallel to the same line, then these two lines are also parallel. Okay? Like this, if there is a line, okay, there is another line. Now, if this line is parallel to this line, suppose name the line, this is AB, this is CD, this is PQ. Okay, if AB line is parallel to PQ line and CD line is parallel to that PQ line, then we can say these two lines also be parallel. Okay, so in this case also AB is parallel to CD. Okay, here PQ is the common line to which both the lines are parallel, and it lies just upward direction of the both AB and CD. But here we consider PQ or the common line in between these two lines.